right, in this video I'd like to talk about even, odd, or neither functions. So when we say that a function is odd, we're saying that it's got symmetry with respect to the origin. That means that whatever happens, say, in quadrant 1 is going to reflect, or it's going to rotate 180 degrees and also happen in quadrant 3. Okay, pretend this is drawn to scale and perfect and beautiful. So the way I want to consider that, if this were the equation y equals x cubed, say this is the point 2. When I cube 2, I get 8. And I've also got a point down here when x is negative 2. Cube negative 2, keep in mind a negative times a negative times a negative stays negative. And what I notice is that when I have, if x, okay, so here we have f of 2 is equal to 8. Do you agree? Which means that f, well, it doesn't mean, but we also know that f of negative 2. So I've taken x and I've made it negative. Well, that's equal to a negative 8, which is the same thing as a negative f of 2. Okay? So the fancy way to say this is that f of negative x is equal to a negative f of x. An even function has symmetry with respect to the y-axis. So a good example of that would be something like a parabola. If I have this over here, it reflects, pretend I can draw. Okay, well, I've done worse. It reflects into the other quadrant. So let's say I've got a point, this is the graph y equals x squared. Say I've got a point whose x value is 2, its y value is 4. Over here, I've got a point whose x value is negative 2, and his y value is still a positive 4. So what's happening is we have f of 2 equals 4, f of negative 2 equals a negative 4, which is the same thing as just f of 2. So I have f of negative 2 is equal to f of positive 2. So the fancy way to describe, okay, here's even, okay. The fancy way to describe an even function is that f of negative x is equal to a positive f of x. That's what it means to be an even function. So I might say, determine whether this function is even, odd, or neither. I may say, prove that it's even or odd. I might say, but if I say justify algebraically, this is the information that you're using. So let's say, if they say determine if f of x equals 6x to the 5th minus 10x to the 3rd plus 2x. Determine if this is even, odd, or neither. Okay, I ran out of space. So what I'm going to do, and this is exactly what I want to see in the proof when you work this for me. I want to see you plug in negative x. So I had, this was 6 times something to the 5th minus 10 times something to the 3rd plus 2 times something. Well, that something I'm plugging in now is negative x. Notice a negative to the 5th power, I like to use my fingers because, I don't know, I can. If I have 5 negatives, a negative times a negative times a negative times a negative times a positive, this, I lied. Those are all negatives. This becomes positive, that's still negative. The answer is negative. Sorry, if that wasn't necessary, just ignore me. Okay, this is now going to be a negative to the 3rd power is still negative, times this negative out here makes this a positive, and that's a minus 2x. So what I'd like, and I want to see every step of this, and now what we notice is that I can factor out a negative, and I have this is equal to a negative. This right here was exactly what we started with, a negative f of x. So I have just proved that f of negative x is equal to a negative f of x, which tells me that this is an odd function. Okay, and an even function, let me, just to make the video short, let me do a neither function, and then the even, you'd end up with right back where you started. So odd, we have the exact opposite. Everybody changed signs. And even, you would end up right where you started. Here's a neither. So if I have f of x is equal to x cubed minus x squared. Okay, so if I have something like that, then I'm going to plug in negative x wherever I saw my x. And so a negative cubed becomes a negative squared becomes a positive, but it's still multiplied by this negative right here, so that's minus x squared. Notice this is not exactly opposite, but it's not exactly the same either. So this is what a neither situation would look like. All right, here's an even one. I'm sorry if this makes this too long. So f of x is equal to x to the 5x to the fourth minus 3x squared plus 11. If I plug in negative x, then I end up getting a negative to the fourth power is positive. A negative to the second power is positive, so that's still this. And that's still here. This is exactly where we started. I want you to show me that it's equal. We showed that f of negative x is equal to f of x. And so this was even. All right, good luck. Go practice.